Welcome to Seth Vidya Mandir Junior College of Commerce and Science online audio video lecture. Welcome back students. I Miss Alka Chaube explaining new chapter, that is chapter number 5 is oscillation. Welcome back students. Let's continue this condition and with the help of the previous condition student, that is displacement is equal to a sine omega t plus phi. So we have to find out displacement, velocity and acceleration condition at instant of time t. So it means we have to differentiate this condition with respect to time, and initial formula is displacement, that is a sine omega t plus phi. So when we differentiate with respect to time, the displacement students, as you know very well, we are getting the velocity because dx by dt is nothing but the velocity. So students, as you know very well, in this condition amplitude is constant, angle is constant, only sine omega t term we have to take as a differentiation. So here I am taking the rough part of this because here I directly apply the formula, but here I applied the rough part of this so you can understand. So here if I am taking all constant term, it means if I replace this term, suppose acceleration is also I am not taking, that is sine omega t, because here sine omega t initially I am taking, and when I differentiate this term with respect to t, then what happens? The differentiation of the sine omega t is nothing but what? Cos omega t into omega. Yes, clear? So same term, this condition here applied, that is cos omega t into omega, or plus 5 as it is, amplitude is as it is. So hope you very clear about it in this condition. When we have this type of condition, students, in physics, you just take the variable term and differentiate that variable term in separate and just include that term in this condition. So easily you are getting answer. In the next condition, we have to take the velocity. As you know very well, students, the velocity, it means nothing but this condition we have to differentiate with respect to time t. So when we differentiate this condition, it means we have to differentiate the cos omega t condition. Clear? So cos omega t condition into omega condition we have to differentiate. So let's consider the cos omega t into omega. So here I am taking the differentiation with respect to time. So omega is as it is, cos omega t. So here the sine omega t into omega. Omega is square here, so sine omega t into omega square. So after differentiation, students, you can see a square sine square omega t plus phi. Hope you clear about it, the differentiation of this velocity and acceleration. So here the small term here explaining, that is the acceleration, displacement and velocity with at any instant of time, the condition will be changed here. That is velocity is a omega cos omega t plus phi, and the acceleration is a square a omega square sine omega t plus phi. Clear? This all condition we are applying in the numerical. But when we differentiate the velocity, time and all at any instant of time, that time we can use this all condition. Let's move on the next condition. The extreme velocity of displacement, the extreme value of displacement, velocity and the acceleration. So let's consider the all condition in the extreme value, the displacement, velocity and acceleration here. So as you know very well, students, the displacement already we have got it, that is a sine omega t plus phi. So first we can consider like at mean condition. As you know very well, at mean condition we are applying the 0 and pi. That time the mean condition is this. At extreme condition we have the condition pi by 2 and plus 3 pi by 2. So in this place, if I am taking pi by 2, 3 pi by 2, so here in this place pi by 2 and 3 pi by 2 we are taking, and at extreme condition we are getting the constant term, that is amplitude is maximum. It means when the particle is oscillate at extreme condition, there is amplitude positive and negative. So here we are getting this condition. When the particle is in mean position, the displacement is 0, and here the displacement is maximum. In short, here it is explained. And in the term of velocity, students, here in the term of velocity, that is v is equal to plus or minus omega a square x square. As you know, this all term here I am applying the small condition. So here at mean position, that is displacement is 0, that time when the displacement is 0 substituted, we are getting this condition, V max is equal to plus or minus square get cancelled out A omega. When the particle is maximum at mean position and when the particle is at extreme position, that is at minimum. The extreme condition, as you know very well students, the velocity gradually decreases, so we consider the 0. So the velocities we consider they're 0. So we know it very well students, the whole term become that what converted into x is equal to plus or minus a, because at extreme condition the amplitude is maximum. So here also we are getting the amplitude is maximum with the help of this condition also, with the help of this condition also. And here we are taking the velocity is 0 and the displacement is maximum there, and when we are shifting this term a plus or minus squaring get cancel out, plus or minus a we are applying. So in the velocity term is also clear here. Let's take the acceleration term. At the mean position, the displacement and acceleration is 0. As you know very well, there's no displacement, there's no acceleration. At extreme condition, at this condition, the acceleration, that condition, that is displacement, that is x is equal to plus or a, and a is equal to plus or minus omega square into a, because acceleration condition, hope you are very clear about it. That is a is equal to minus omega square into x. So it means when we are taking the extreme condition, we are getting the amplitude, no? So amplitude in the place of that is a is equal to plus or minus, that is omega square, or in the place of x, that is a. So hope you're very clear about it. This all condition is very, very important for the numerical students. Hope so. After that we can see the numerical, and based on this previous derivations, so you are very clear about this derivation. So here students, we have some numerical based on what concept we already have did in the previous condition, this condition. So here the question is, a particle perform linear simple harmonic motion and the time taken, that is 4 seconds, and amplitude is 4 centimeter. And here we have to find out how much time taken to travel a distance 1 centimeter from a positive extreme position. It means we have to find out time period here. So let's move on the solution of this question students. When the particle start to oscillate, it means it's having some displacement, and as you know very well what is the formula of displacement, that is x is equal to a sine omega t plus phi. Hope you clear about it, because this formula we had done in the in the last video, that is the displacement formula. And students, in this condition, when the particle is extreme position, the value of phi we are taking pi by 2. So here students, as the given condition, the amplitude is 4 centimeter, but here we have to find out the time taken by the particle is reaching the positive extreme condition, that is 1 centimeter. It means the total displacement is 4, and from the 4 we have to find out we have to reduce here the 1 centimeter displacement, and where we are getting the extreme position of this particle. It means x is equal to 3 minus. So it means the displacement is equal to amplitude minus 1. It means here we have total displacement is 4, and from the 4 we have to minus 1, because where the time taken by travel 1 distance centimeter away from the extreme position. So extreme position 4 minus 1, that is 3 centimeter. So it means the particle have time traveled by the 3 centimeter, where we have to find out the time taken here. So in the given condition we have to substitute. So when we substitute the given condition in the displacement formula, so the value of x net displacement is 3, amplitude is 4 sine omega t. It means students, as you know very well, is this condition, the extreme condition here we are applying, that is in the place of 5 pi by 2, and the omega value, that is already I have explained angular frequency, that is 2 pi by t, and small t is as it is. Then after next condition is, so here we are getting the next step, that is when we are rearranging this term, that is 3 by 4, and the value sine 2 pi by small t and capital T plus pi by 2, when we are taking the value of this, students, as you know very well in a mathematics, sine pi by 2 plus theta, that is cos 2 pi by small t into by 4 here we are applying. So here students, in the place of capital T, that is total time period, that is 4 seconds, we are substituted in the place of capital T, that is 4. So hope you clear about it. Then when we are cancel this term 2 pi by 4, so students here we are getting this term, that is pi by 2 into small t. So when we are taking the calculation of all term, that is pi by 2 by t, so here we are getting students 41.4 degree. When we are expanding, so here we are getting that is 41.4 degree, and when we are expanding this degree in different extension, that is radians, so students 41.4 into pi by 180 radian. So here the time taken by this is, that is t is equal to 0.46 second it's taking when the particle is displaced 3 centimeter in the extreme condition here. So here students, we have the next solved example, and the solved example is different. Here we have to find out the amplitude of simple harmonic motion. So let's move on the question. A particle performing linear simple harmonic motion with 6 second is at positive extreme position where the time taken is 0, and the particle is found to be a distance of 3 centimeter. For this position at time is 7 seconds before reaching the mean position. So here we have to find the simple harmonic motion amplitude. So here students, we have the solution, that is displacement of particle, that is x is equal to a sine omega t plus phi, as you know very well. And here when the particle is displaced from the positive extreme position, there is time period is 0. At that condition students, as you know very well, that time we consider the angle phi is pi by 2. So here we have the condition of displacement formula, as you know very well, x is equal to a minus 3, what we are applied in the previous condition. What does it mean? It means that the displacement is nothing but the amplitude minus the distance traveled by the particle. So here the distance traveled by the particle is 3 centimeter. That's why x minus a minus x is equal to a minus 3. So let's put this value in the displacement. So here x is equal to a sine omega t plus pi by 2 when we substitute the value of phi here. So here in the place of displacement, we are substituting the value a minus 3, which is equal to, so the a is equal to sine in the place of omega t, as you know very well students, omega is angular frequency, the value is 2 pi by t into small t plus pi by 2. So a minus 3 upon a, that a shifted in the left condition is equal to sine, and here in the place of 2 pi and the value of t, that is time period 6 multiplied by 7, the small time taken by the extreme condition of the particle, plus pi by 2. So here after this condition, the a minus 3 upon a sine, and when we cancel this term 2 pi by 6, so here we are getting 7 pi by 3 plus pi by 2. Then after next condition, a minus 3 upon a as it is sine, 7 pi by 3 plus 2, 7 pi by 3 plus pi by 2, so the pi by 2 as it is, and 7 pi by 3, in this condition students, we are replacing the term, that is pi by 3. So here the condition is as it is, and then after, as you know very well student, the sine pi by 2 plus theta, that is cos theta, so the value of theta is pi by 3 here, and cos pi by 3, that is 1 by 2. When we take the cross multiplication of this condition, the 2a and 3 2s are 6 is equal to a multiplied by 1, that is a. So after rearranging the term, we are getting a is equal to 6 centimeters. So here we are getting the amplitude of. So here students, we have the next solved example to calculate the time period when the particle in extreme condition in the case of velocity. So let's see the question here. The maximum velocity of particle performing simple harmonic motion is 6.28 centimeter per second. If the length of the path is 8 centimeter, calculate the period. So here we have the solution, as we have the velocity at the maximum condition is equal to 6.28 centimeter. So the next condition is 6.28, that is 2 pi centimeter per second. So students, as you know very well, that is the value we can substitute here. So the amplitude is already given, that is 8 centimeters. So let's substitute the value of the maximum velocity. So V max is equal to A omega, plus minus we are not taking here in the calculation, that is A omega. So the place of A, that is 4, and 2 pi by T as it is, because the omega value, and which is equal. So after that term, so here the value of the maximum velocity is 2 pi and the amplitude is 4 and 2 pi by T. So after cancellation, students, here we are getting the time period taken by the particle is 4 seconds. So here we have the next condition of solved example. A maximum speed of particle performing simple harmonic motion is 0.08 meter per second. It means velocity of particle. And the maximum acceleration, the A value is 0.32 meter per second square. So here we have to calculate the time period, that is T, and the given amplitude value of the particle. So let's go for the solution. That is, as you know very well, students, so here we have to find out this condition. So here acceleration and velocity are in ratio, students. So after taking this, acceleration is A omega square, velocity is A omega. A get cancel out. So omega is equal to the value, as you know very well, 2 pi by T. So here we are taking the value of acceleration is 0.32 and the velocity is 0.08. So after cancel this, we are getting 2 pi by T. So after that calculation, we are getting the time period is equal to 1.5 second. So the velocity is A omega, so A as it is, and the place of omega we are getting 2 pi by T. So the amplitude is 2 centimeter. So here, student, the time period 1.57 second and the maximum velocity is 2 centimeter when the particle is performing in simple harmonic motion.